For this gas-linked liquid column, gas A is left, gas B is right. If we heat both equally, how does the column move? As heat rises, pressure on both sides grows. How do we solve this? Here is a tip. What should I do during the process of raising the temperature? I make an assumption. Every single one of them has a constant volume. Constant volume, why do I do this? According to the ideal gas law, P times V divided by T equals a constant. If I assume its volume is constant, then its P1 should equal T times C divided by V, and then you'll notice that here, I assume the volume is constant and C is also a constant. During the process of increasing the temperature, its pressure also changes uniformly, right? Then, let me show you another diagram, and it will become even clearer. The label P in the diagram, as the title suggests, it must be a straight line passing through the origin. Then, if I take any point and look at P and T, or delta P and delta T, since it's a straight line through the origin, I definitely have P over T equals. Since these two triangles are similar, as we can clearly see here, right? But notice when I'm studying them, it's really because of the change in state. The pressure at point A must be equal to the pressure at point B. Now, when I'm studying the process of increasing temperature, whichever side experiences a greater increase in pressure, the force pushing the liquid column at the final state will be greater on that side, so the liquid column will move in that direction, right? Now, let's take a look. Initially, PA equals PB. I don't need to worry about the volume because I'm assuming the volume has already remained unchanged. For example, in option A, the final temperature at A, TA, is less than the temperature at B. So what exactly should be the relationship between PA prime and PB prime for the two of them? Let me see. If I look at the relationship between their increases, then I'll know the relationship between their final states, right? Because initially the two are equal, so whichever one absorbs more heat, the increase will be greater and the pressure in its final state will be higher, right? So here, let me look at the delta. It should be equal to P times delta T over T, right? So for A, delta is also equal to the initial pressure of A times delta T. It's the same for both. Why? Because for B, I should have delta PB equals PB times delta T divided by T. This is A divided by its width and B's initial temperature. Now let's see, since the initial pressures on both sides, A and B, are the same, I don't need to worry about that. And since the temperature increase is also the same, I don't need to worry about delta T either. So I can see that whichever side has a higher initial temperature, its pressure change will be smaller. Now, since the initial temperature TA is less than TB, TA is less than TB, then delta PA must be greater than the change in PB. So at the start, the pressure for both sides is equal. Looking at option A at the end, I notice that the increase in pressure for A is greater than the increase in pressure for B. Therefore, the piston will definitely move to the left first because initially it was in force equilibrium. But later, at the end, the pressure increase for A is greater than that for B, so the piston will move to the left. So when I study this kind of problem, I assume that the volume remains unchanged, and then I analyze the relationship of the increase in pressure, because after all, the initial pressures on both sides are equal. From this, I conclude that the side with the lower initial temperature will experience a greater increase in pressure. So here, since the temperature on side A is lower, the pressure on side A increases more, so the piston will move to the right. What about B? If the temperatures are equal, then the pressures are the same, the increase in temperature is the same, and the final temperatures are the same, so the increase in pressure is also the same. In that case, B won't move. As for C, the initial temperature of B is lower than the temperature coming out of A, so the pressure difference increase for B will be greater. So what about B? In this case, the piston will move to the left. Similarly, for this B, its output temperature is even lower. So for B, the increase in pressure will also cause it to move to the left, so it can indeed move to the left. Therefore, the correct answer must be Siegendal.